in college algebra, we moved on to 1.6. It's titled Other Types of Equations. I tried to rename it something else. These are all just a play on quadratic equations, and you got to use things like factoring, quadratic formula, square root method to solve these. So on number 1 and number 2, I would choose factoring to solve. So what that means is you need to set equal to 0. So we're going to move the 27x squared to the left side. And then we should be able to factor it. Always look for a GCF, and 3 is the largest number that divides into 3 and 27. Look at the smallest exponent, and that's a 2, so we can take out x squared. When I write the leftover, the 3 is gone, but there are 2 x's left. 27 divided by 3 is -9, and those x's are gone. So at this point, there's a couple options. It is solvable without factoring further, but I would just factor it as far as possible. And you can factor that x squared minus 9 into x plus 3, x minus 3. And then you set each factor equal to 0. So here's one factor, another factor, and another factor. So that first factor people struggle with. If you need to, divide by 3, and hopefully you realize the answer is just 0. For the other two, it's pretty easy. Add 3 and you get 3. Subtract 3 and you get -3. But you should finally get x equals 0, -3, and +3. All right. On number 2, same idea. We want to move everything to one side, so let's move the 4x over. And we're going to factor by grouping. We've done this before. You group the first two. I should have started higher. I'm going to run out of room. And you take out a GCF from each group. So the GCF in that first parentheses is x squared, and you have an x plus 1 left. The GCF in the next parenthesis is -4, and you have x plus 1 left. Now we have two terms right here. We have this term and that term. And look, they both have a factor of x plus 1. That becomes the GCF. So you take x plus 1 out, and the leftover is x squared minus 4. It's a nice trick with factors. You can still take it further into x plus 2, x minus 2. So that means x is -1, -2, and 2. All right, let's try number 3. We've never solved one quite like this before, but read it and give it a try. Maybe hit pause. What I like to do is when I see the equation, or sometimes there's not an equation, I skim through the paragraph and I write down the variables on the side. So I see an x, I see an x, and I see an s. So right here it tells me what x is. That's our area. We're talking about these islands and how large they are, because there's a lot of them. And S represents number of plant species. Now, the next thing you need to do is skim through the paragraph and maybe cross out numbers that we don't need, but let's make sure we are aware of the numbers we do need. So like 600 miles west of Ecuador, we don't really need that. A 600-pound tortoise, that's pretty crazy, but we don't need that info. This is what we need, because that's where the question is. Find the question mark. It's asking, what is X when S equals 57? So let's replace S with 57. And we need to get X by itself. So since it's attached to that square root by multiplication right there, it's not typed, but since there's nothing in between, it's being multiplied, that means we need to divide to get rid of it. Because ultimately, I want X all by itself. Ultimately, I want X all by itself equal to some number. And so getting rid of 28.5 is the first step, and conveniently, that's a 2. Now, if I can raise a value to a power, the same power that it's being rooted, so this is a cube root, then I can cause the 2 to cancel out and just get the inside value. In other words, if I could raise this to the 3rd power, then an X comes out. It's just whatever I do to one side, I got to do the other, so I want to raise 2 to the 3rd, and look at that, we're done. X is all by itself, 8 square miles. All right, number 4, it's probably the hardest yet. That radical with an X in it and an X outside of it can be really tricky. So first off, let's isolate the radical. Let's move X to the other side. And the radical is all by itself now. Now, in order for this work to work, the radical's got to be all by itself. So if I square both sides, actually, let's write it on the next line, so y'all can see what took place. If I square both sides, I need to make sure I put it in parentheses. And go slow, because it isn't just 16x squared on the right. We need to FOIL, because we're going 2 of these times the same 2. And there should be 4 terms when we multiply that out. The left side's really nice. The radical and the 2 cancel out, and you get this. But the right side, it gets a little messy. There was no way around it. We FOIL it out and we get 16 minus 4x minus 4x plus x squared. Combine those 2 middle terms. And I see the x squared and the x, I'm going to have to factor or do quadratic formula. Either way, you need to get the 26 and the negative 11 to the other side. So I would rewrite it like this. We're going to add 11x, and we're going to subtract 26. Combine like terms, And we have a very easy factoring problem. I need two numbers that multiply to -10, but add to 3. So that's a +5 minus 2. X is -5 and +2. All right, hope that made sense. I will see y'all later. Bye.